What's up, everybody? A Sparrow with a Gun here from Sleepless Night Studios with my first episode in the Space Engineers Programming 102 series. I don't know how this series is going to go overall, but I did have enough content that I wanted to do an episode on it. So since I'm still kind of working out the bugs and kinks in how I might be formatting the episodes and stuff like that, kind of bear with me a little bit in that as more episodes come out, they may be formatted a little different, change a little bit, whatever. So the first things first, let's get into the script we're talking about today. I am dubbing this the first entry in the new Sleepless OS script. Because I eventually hope to incorporate all these different multi-modules into one big script thing, and then you can just use one thing. But that's more of a formality at this point, hence the version 0.01. I might even change the name of it by the time we're done with it. So, as you can see, we have a hydrogen storage readout and a nanite missing items category. The first one was I was trying to get my feet wet a little bit, and so I figured it would be a good way to give me a readout on the hydrogen storage and stuff like that. It was something simple, but it still worked with string manipulation and stuff like that. The other thing is this whole series, I've talked about if I potentially did it before, but in case any of you are watching that weren't familiar with any of those other episodes where I talked about it, this will not be like the 101 series where I'm explaining things like what a string is, what an integer is. This is pretty much just codes that function and then showing you how they're written and how they're functioning and stuff, but not basic programming stuff with C# and whatnot. It'll have more to do with the APIs within Space Engineers and such like that, and how the overall script works, not the inner workings of the programming language. So just bear that in mind if you're not real familiar with it. Some of this stuff may not make sense because I probably won't be explaining it too thoroughly. So what this does at the moment is it currently gives you the readout of one hydrogen tank. I was practicing with it, so it's not set up to read multiples. Like, it's not looking for every hydrogen tank. It just was going for the one that I wrote in specifically because I was testing. Mainly for one of the big things that I've learned, if you're wanting to do stuff with blocks, if you're wanting the items to be categorized and stuff like this, you have to be very comfortable with string manipulation, and that's not something I'm great at. So I was really trying to practice with the hydrogen tank to get used to how to get the information that I needed. This also works with the Nanite, or I call it the Nanite mod. It's actually the build and repair system, I believe, in the workshop, but it's a nanobot constructor. So if you're not familiar with that mod, that's specifically what this script is about, and it won't really work without it, essentially. And all of these scripts are designed based on my Let's Play build. Like this is done in my base. Some of you may recognize the server room that I built in the last episode, although it is fully completed now as a byproduct test of this script. So what this script was basically designed to do is we have the Nanite mod that builds things, but we still have it to where it doesn't always get or have what it needs. It'll say, I need this, or I'm missing these items. But it doesn't just automatically make them. Now, I don't know exactly how this... I didn't want to control the nanobot system with the scripts, because if you look at the nanobots, it actually tells you somewhere you can control it by scripts, but this controls the actual repair, build, and stuff like that of the nanobot mod block. I didn't want to do that. I wanted to control the assembler to build what it needed, what it was missing. And so that's where this comes from. Now I'm going to go over it working and functioning, and then I'm going to tab over to Visual Studios because the Space Engineers editor just really is not that conducive. There's a couple of places where the text goes out of the screen, and I have no way of showing that to you. There's no word wrap or anything in this editor. So it's a very basic editor. I'm hoping eventually they'll improve it so I don't have to use Visual Studios and I can just do it all in game, but for now, it's not there. So I'm going to tab over to Visual Studios after we go over it a bit more. Now, I started recording this episode. I've actually re-recorded it almost twice now because as I was recording it, I ran into some bugs and issues, and I was like, I really need to make sure I've got this kind of squared away. Because this series is going to be more, the scripts are done and they're functional. At least for the most part. If you guys run stuff and find problems with them, let me know. Or if you see a problem and I don't see it and it's not made apparent yet, still let me know. And frankly, if there's any, I'm making lemonade out of lemons, I'm making it work based on what I know. But if you're a senior programmer person and you recognize something as being inefficient or it's redundant or something, let me know. I do not care if you can find a simpler, streamlined, better way to do it. Right now, with this series and stuff, I'm just focused on, I want this to do something, it does the thing, we're done. That kind of thing at the moment. So as you can see, the Nanite system is offline right now. I programmed it to have a couple of conditions. It will know when it doesn't need anything. It will know when it's off, and then it will list the items needed once it's there, when you actually need something. So we're going to go up in a bit, because up top, on the top of the base, I have some blocks set up for it to build. But right now they're not there. So what we'll do, at the moment the assembler is off and the nanobot system is off, the script is on and running. And the one thing that you would really need to make sure you have, unless you're using a timer block, is this line right here. Again, I'll go over more of the code inside Visual Studios, but this line within the program function sets the update frequency. At the moment I set it to 10 ticks. With the way this script works, you may be able to get away with like 100 or something if you're trying to keep things streamlined. You can even set it for 1, and it will update every tick, and that may prevent a few problems that I'll go over later, so I'm going to keep it that way, and I will change it back in Visual Studios when we get over there. So now it's updating every single tick, and we might be able to show that a bit easier with the hydrogen. I'm not sure, but it's currently at 8.1, and if we run over here to the hydrogen tank and fill up our bottles here, that may have been enough to move it from 0.1 to 8.0. I'm not sure. It did not. Okay. It should have worked there, but with only showing you the percentages, I'm not showing you... Oops. I'm not actually doing this part with all the liters, and so it probably just didn't take enough for it to actually lower to 0.1%, but that's fine, because we can show you another thing right here. So currently it says it's offline, so all we need to do is go in and turn the system on, and you will see no items needed. Now, for a second there, it switched over, and that's something I didn't actually know it would do, and that's because I've changed, it's saying, when you first boot up the thing, its block is not ready. And so currently I have, if it's off, it's going to say Nanite system is offline, but the moment you turn it on, it takes it a second to convert over, and then it comes up with this display. So because we changed the flag to now update every tick, you even saw it say block is not ready, which was not there when I had it set for 10, because there was enough ticks in between there, it didn't pick up on that. That's kind of user preference. If you find that it's a little glitchy with 10, you could set it to 1, but it is going to say block not ready and then no items needed. That's just, I don't think that's a problem. It's just kind of, it is what it is. It's there. Okay, so now what we're going to do, before we turn the assembler on to actually build anything, what we're going to do is come over here, and I'm going, at the moment, all of these blocks up here are painted with the color that the nanobot ignores. That's why it says there's no items needed. Now, if we change this back to the default color, and we paint all of these, I did a bunch of just random stuff, reactors, medical, antennas, so that you got a big variety of parts, so the list would be a little bit more lengthy, and we could kind of see what's going on a bit more clearly. So let's go over down here again, and now with, if everything goes right, which it should be, the nanite should be listed here. There we go. There's our list of items that the nanite block is missing. Now, I haven't done a whole lot with formatting, like putting spaces between steel plate and everything, because it was much easier to feed this information to the assembler, but it's not impossible. So over iterations of the Sleepless OS, we may polish this up to where it actually looks a bit better. But for now, this was more of a function over form test to get it working, and it's really not that big of a deal. So that's kind of a formality, cosmetic thing later. Now, the other thing that you'll notice is now that the nanobot system is on and we have this information here, which is the same that you're getting on the readout, you'll notice if we tab over to the assembler, its production queue should be... that's curious. I don't know why the steel plate was off. Because it shouldn't be. Unless that was... Girders is 22. So that one made it okay. Computer, explosives, all that stuff looks right, but the steel plate's wrong. I'm not really sure why the plating there is incorrect. 12, 6, 56... Nope, something's not right. Alright, hold on. Okay, so I got it squared away. It was actually an issue with the tick count. So I changed this back to a 10, because that's the way my code's actually set up. I was changing it to a 1 to see if I could get it to do a little bit faster updates. I'm not entirely sure why that has an effect so profoundly, as all of these, like, it was missing stuff and things, because the way the code's set up, it really shouldn't matter. But it is what it is. It did seem to affect it, so I would say don't go any lower than 10 on the tick updates, and you should be fine, because all of this updated correctly now. And if we look at our assembler, I double-checked the numbers, and all of these items are now in place. So now, all you would have to do is turn the assembler on. It would start producing said items. And if I did my script right correctly, then there shouldn't be any additions, because when I first started doing this script, it was adding this queue multiple times, and it was just stacking up. And so I think I finally got it to where, and this is going to happen too, because if you look at the nanobot mod itself, while it's building, the missing items list goes away. Now, if we were to turn the assembler off, let's test this theory too. So we turn this off, it's middle of production, 173, 22, etc. and so on. And it should have repopulated this list. Oh, there it goes. Now steel plates seem to be missing. Oh no, it's reordered. Okay, weird. So it's 173. And we're at 173. Okay, 22. Maybe because this is in production, it has a different value on the list now, or it's possible, let me double check this real quick, if the nanobot... Okay, so I'm feeding off of this mod. So if this mod does something like this, where it moves steel plates from the top to the middle, that's out of my control. I was thinking there was something wrong with the code, but it's actually the way the nanobot thing handles it. So with that in mind, once again, turn this back on, and it'll get to going, and this list will say no items needed, because there's no information coming out. There's probably ways I could add in some other thing instead of no items needed. There might be a condition of, like, if the nanobot system is working or something, then tell it, you know, the nanites are working, etc. I'm going to let this go for a minute, because what I want to see happen is at the end, theoretically, if I did my code right, my concern is with the update ticks, but theoretically, when this... when the production thing ends, this should no longer need any items, and so the list should go back to being normal, and it should stay saying no items needed, and the production queue should be empty, in theory, but I'm not sure how that's actually going to work, so we're going to find out. Okay, so I'm kind of jumping in here. This is actually recorded after I was done with the whole episode, and I forgot that one of the big things I wanted to put in here before we jumped into Visual Studios and everything was kind of a how to set it up. So I kind of went over just now what the script actually does and, you know, ways it works and things you'll have to do. But as far as setting up, like if you were just building from the get-go and you had no idea how you wanted to make it run, there's a couple of things that if I was, when I eventually make this a bit more public, I'll make it a bit more versatile in that you don't have to name them very specific things. It might be based on a type or something. But for now, this is how it works. You'll need a nanobot thing, or as the actual, I named it nanobot system, but as the actual block in the workshop, I believe, is called Build and Repair System. So you need one of those. Obviously, you need an assembler. And technically, eventually, you'll need one of the drill platforms for this script to work perfectly, because I mentioned it at the end of the episode. I use that to get my resources, but if you don't have it, I mean, you can just feed it into the assembler for now until I add that part. At the moment, it also needs the hydrogen tank if you want that part of the script to be valid, otherwise remove that code. And mostly it's the naming thing, because everything is done by name at the script right now. So this is hydrogen tank, the other one was nanobot system. The programmable block name really doesn't matter all that much because I don't use it, but I named it PB primary script, but that'll change. It should be like Nanite script or something like that. It's kind of silly at this point. And a display dash server room. All of these names are basically subjective, I mean, or relative. You can rename them anything you want, but just if you weren't familiar with coding and wanted it to work, if you name the blocks that way, you can cut and paste this. So you'll need a programmable block. This is a modded one, but it doesn't do anything differently. And when you go in, you'll need the script and have that running on one of the programmable blocks. Everything else should be fine. But the big thing, if you wanted to change anything, would be right here. You have the hydrogen tank name, you have the LCD name, the nanobot system name, and the assembler name. So as long as these right here match up your blocks in your game, then it should be as simple as pasting this code in, making sure the names are right, and hitting run. And then you'll have, you'll have to turn the nanite system on and the assembler system on. And obviously those have to be connected with the conveyor system and so on, but that's all the syntax that you would need to set this up and connect everything at the moment. It'd just be making sure the names match up to whatever names the script is looking for. Everything else seems to be fine. So with that, now let's jump into Visual Studios and I will show you kind of the guts of how it works. Okay, so we're here in Visual Studios, and I don't think you can see my mouse because I'm trying to record with the same software with Fraps as I do in Space Engineers. I left Space Engineers running in the background because I still needed actual materials to build all that stuff, and it was taking forever, so I just figured I'd let it run, and we'll see what happens. For those of you that may not be aware, this is kind of a setup that you can use to plug in all the APIs and things. I would say if you're interested in doing something like that, then look it up because I got it working, but it's one of those things that I'm not really sure all the things that need to be done and all the things that I ended up just doing when trying to make it work. But it keeps the syntax and stuff so that while you're coding in Visual Studios, it'll tell you if that's something that the Space Engineers API is okay with, or if it throws flags and stuff like that, which makes it very easy to learn the Space Engineers API because then it's telling you what you're doing wrong and what you need to do right. Okay, so first of all, we have the construction method, which has our update flag, which is going to essentially work like a timer block now. That's a new feature that got added recently, but with this line in here, the programmable blocks will self-update, which is really cool. As you can see here, run every 10th game tick. And I believe you can do 1, 10, or 100, or both. Actually, now that I think about it, well, no, because running 1 seemed to be a problem. I don't know if it would work out if I did an or, because you can do something like this now, is another way to, oops, didn't mean to do that. You can do an or flag and have it be like this, where now it's going to be update every 10 and 1 tick. But considering the issues that we had with the assembler and stuff when it's in 1, I'm recommending we just leave it at 10. The save function I didn't really find a use for yet. I'll probably use it at some point if I need to, but it seems to be a fairly self-sufficient script. Now, I did have issues with using global variables. I tried to put these variables in, like these guys here and all this stuff that was going to be used throughout the script. I tried to put them up here in the constructor and even gave them public tags and stuff like that, but the game engine code library didn't really seem to like it, so just to get it to work, I ended up doing this. I don't know if it's the most efficient way or not, because technically it's going to reinstantiate these every time the script runs, which seems like a a bit excessive, but I couldn't seem to get it to work as global variable, so I just went with locals. So first of all, we have the gas tank, using the IMyGasTank, which is a little bit new. When I first went to do it, I believe I used the IMyOxygen tank. But again, with the syntax highlighter, it tells you that this is actually deprecated in the mod API, so you use the gas tank one now instead. I don't know what all the implications are to using that over the oxygen one, but they changed it. So our hydro display, I had this set up because I was originally using the LCD on the other room, but as you can see here, when I picked all these out by name, hence why I said it wasn't going by all hydrogen tank types. So I just used the name here, and then I changed this one to the display in the server room, but I didn't really change the variable name to reflect that. So I can adjust that later. Again, we get the nanobot block, which is classified in the game as a ship welder. Now, the nanobot system is a mod, so it took me a little bit of time to figure out exactly what it was classified as, because a mod is a modification on an existing type. So if you're using the nanobot system and you want to do any coding for it, it is classified as a ship welder. So we got it by name and cast it as a ship welder, and everything was fine. Then we have our assembler. Now this part here is a little bit complicated, or at least confusing. It's not really that complicated, but it can be a little daunting. So, but the way that this works is, in order to access the queue of the assembler, you need a definition ID block or variable. And rather than recasting things as definition IDs or VRage fixed points, which VRage is the engine Space Engineers is built on, so rather than casting these two as like every time you need them, I just decided to throw them in as variables. And then we have the display text, which is what comes up on the screen on the display. The hydrogen value, which is the amount of hydrogen in the tank, and missing items, which is the nanobot system's missing items. Now, there's a couple of different things when you're working with some of these terminal blocks, because all of these classes, text panels, assemblers, most all of them are they inherit from the global block of the IMyTerminal blocks. Like every block in the game, as far as I know, that can be accessed through the terminal is a terminal block. I believe exceptions would be things like steel plates and steel blocks, that there's no access through the control panel. But anytime you can go into like that screen where we were selecting different displays and stuff, they're all descendants of the IMyTerminal block. So anytime you're working with those, for example, we can pull up the hydrogen tank variable, and if I can spell it right. And when you get here, you can see there's a bunch of different things. There's custom data, info, name, etc. The custom data is the actual field that you will see in the game. Now when you pull up each block in the game and there's a custom data button and you click it, and then there's just this open text panel, that's what that is. Custom info, on the other hand, is used. I don't know how every block uses it, but in our case, what we're working with here, it's where the nanobot block stores its information, such as the missing blocks, blocks it's working on, etc., and all that. That info panel is coming from the custom info page. I don't know how this actually applies to other blocks. I've only played around with this variable, or this parameter in this particular block, so I don't know how it works. It may work for stuff like batteries and things to get. It may be an easier way to get the power readouts now. I don't know. I haven't tested it. So then I've made two separate lists, one that's items needed and one for item amounts, and they're blank lists here. And then I also, for string manipulation, did a couple of things. I did a separators list and a cleaners list. So these are things that we want to separate the text by, and then the cleaners are things we want to just remove, but we don't want to actually get information with them. So the setup here, the display, we're adding to, actually, I could have just added it, I suppose, but the display text I added in my OS header. And to calculate the gas, first I checked to make sure that the tank was on. This is kind of, you don't really need to know that, I suppose. in order, if you're just looking for the amount, because even if the thing's off, you could still want to see how much is in there, but I was trying to add some redundancies and some checks. So if it's on, what it's going to do is, since these values, the hydro value up here has their detailed information, but it has all of it. It has everything, including the filled, I forget what other, there's 3 other lines, I believe, of information that come out of the hydrogen tank's detailed info. So we take that and we reassign here. We didn't add to it like we did up here, but we're reassigning it. The hydro value, we did a substring at the index of filled, so the index point will be right here. Once it finds this whole line, the index point is this. And then I added the filled dialog, and then added the length function, or parameter, whatever it's called. So basically what we're doing here is we're taking the index from this point right here, and then we're taking it all the way to the end point of the colon by adding its length back to itself. I hope that makes sense. So the way substring works, if you're not familiar, is you have a start index and then a total length. So here we're setting the index to the filled point right here, right after the colon. And then this comma separates the length argument, so this is the length that we want. So what it is I went all the way to the percentage sign, so that way if it was 8%, 80%, 100%, however many digits are there, it would go all the way to the percent sign, and then added 1 so that it didn't start back here, but it actually goes all the way past the percentage to keep the percentage sign in the text that we want. And then we subtract, again, this value here. So we're basically saying that we're subtracting from this index right here all the way to the end of this one. And that way it kind of cuts that chunk out and puts it back in here. So we're removing everything else from the detailed info and feeding it back into hydro value. So that way it's purely a numerical percentage value. And actually, if we really wanted to, I could have... with this string in mind, I could have removed this 1, so it actually did remove the percentage, cast it into a float value or something like that, and then added a percentage, and that way if we ever wanted to tinker with it, it was fine, but I don't really need to do that because it's a read-only really value. There's not a lot you can do with the hydrogen value itself. And so then if this is not enabled, it'll just say the hydrogen tank is off. With that in mind, then we do another display text here, and we had some extra lines here, so we spaced it out. We do hydrogen storage readout, a few more spaces, add the custom name of the tank with a colon, and then actually input the value, and that's where we get our 8.1% readout we were seeing. On the moving to the Nanite part of it, so the first check is if the Nanite system is on, which we saw that if it was off, you go down here to else and it says missing items equals Nanite system is offline. And then at the end of this chunk here where we're determining the resources, then we go back to the display text, we add in another little header piece, and then we add the missing items value, which is all of this stuff where we're getting our information. So if it's not on, it just defaults to this and it says it's offline. If it is on, then this is a little bit of a tricky one. Oh, no, not this one. I'm sorry. This one is the tricky line. So for this part, I'm looking for missing items index of the colon is greater than equal to 0. What this line actually does is if the block is on, but it's not ready, it'll say block not ready, or if it's off, it'll say something like the block is turned off or something, but there's no colon. So as soon as the thing gets prepared and turned on, then it says missing items, colon, building blocks, colon, etc. So you'll only see a colon come up if it's actually on and ready. And so what happens with this line is it basically checks to make sure that it's greater than 0, because if index is a -1, it means it could not find this. So as long as it's greater than or equal to 0, it means it did find it somewhere. Then moving to that, we do missing items, and because the missing items thing was assigned up here. I forgot this part. So missing items was fed the custom info up here. So it has all of that information in it. So from here we do a substring. This one's a little tricky too. Again, we look for the colon. The first colon it finds is going to be right after missing items. And then we add 1 to remove the colon from the equation starting index. And then the length is look for blocks to build. Now I didn't add this value back to itself because I actually want the index count right here at the beginning of the B. It's going to be like right in front of the B. Because everything between missing items colon and building blocks right here, that first part is what we want. And then of course we subtract out this starting index to where we're only getting what's after the colon and before the B. Now, again, this is a little bit tricky, and this is where the difficulty of this script actually came in. There's some formatting things that make it kind of a pain in the butt. For example, I will show this when I go back over to the Space Engineers setting, but for example, there's a dash in front of everything. So if you have steel plates and 60 whatever on there, it's actually listed like this in the game's custom info. It has a little dash thing. There's also a couple of blank spaces and some new line characters. There's a lot of different little formatting thing that can screw up substrings because it's seeing data that you're not seeing, because to us it's just blank space, but to the computer it'll see new line characters. It'll, like these /n's, we don't see these, or we see them as carriage returns or enters. It's new lines, but the computer actually sees them this way. And so with that in mind, there's a lot of fluff code or fluff values in the strings that can kind of mess with when you're actually looking for, I just want that word. So that's what the next couple of lines does. The first one is the trim method for a string, which, as it says here, removes all leading and trailing occurrences of a set of characters specified in an array, a character array from the current string. Hence why we have our cleaner array and our separators array up here. So when we do this line, any blank spaces, new lines, or dashes on the front or back of the string will be removed. Now the one caveat to this is I believe it's a per line. So if something is in between, like if you had spaces between words, I don't believe this method would actually remove it. You'd have to go in and probably loop through the string itself and do it that way. So now we get to this one. This was a little weird. So even after you've done this trim stuff, like I was saying, some of those things can't get removed in this way because they're not at the beginning or the end of the string. They're in the middle. And so when you run this through, you end up with 4 new line characters, and the overall length of missing items is 4 if it's empty. If it's not empty, you will get what you saw on the, or at least a rougher version of what you've seen on the display in-game that I showed you before, the list on the LCD screen. But if there's nothing there, if the string is empty, it says missing items because it's on and all that stuff, but it doesn't really need anything, it still has a length of 4 when I'm done cleaning this up like this, because there's still some new line characters I couldn't get rid of. So this if is here because if that happens, then it's basically saying, well, if it's not greater than 4, there are no items that are less than 4 or even 4. So if the characters are only are 4 or less, then it's an empty string essentially. It's just a bunch of new line characters and blank stuff. So if that happens, there's no items needed, and that's where this line comes in. It defaults down here. If it's greater than 4, there's something there. There's actually text or items listed. So when that happens is where we get into the meat of cleaning up the list to where it's readable for the assembler. So we do a blank string array called results, and we feed in the missing items split. And a split function will basically separate it into an array of strings based on whatever separator characters you've had. Hence these up here. So any colons, new line characters, or blank spaces become their own string in an array of strings. And I did add this option. I don't know if it actually worked or not, but it was one of those, once I got the script working, I didn't want to tinker with it too much because it was actually functioning properly. But what this does is if any of the array entries that happen from the split are deemed as empty entries, as in there's no real data value in the string, then it removes them. And so I don't know if that really helps or not, but it seemed to, like, once it was there, once I got the code working, and I was afraid to remove it in case, because this took me a long time to kind of work. It is a little jury-rigged here and there, hence why I said if you guys notice anything that's better, let me know. So the missing items thing here, we basically clear this. Now that we've split it into results, we have all the value. We don't need this to be a string, so we empty it because we're going to put stuff back into the string. Then we loop through the results, which is going to loop through each string item that got separated. Again, I'm not sure if this is necessary or not, but it checks to see if the string is null or white space. And if it is, and it's checking the cleaned version. So I cleaned up using our cleaner, our characters up here, and basically it's gonna go through and check that once it's trimmed and cleaned, if there's still nothing, if there's still white space or that's all it is, then move on. Because I still was getting a couple blank entries with this. So that's another redundant check to make sure that you're not dealing with just an empty or a blank space or something. Then what I did is I alternated. So this would be even, or no, this would be odd number. Every odd number of the array should return the name of the item, and then every even number of the array should be the number entry of how much of it needs. So the odd ones go into the items needed, which is done by it's a list, so you just add results at this index and then clean it or trim it. And then otherwise, if it's even, then we do this thing, which tests to make sure it's nothing but numbers. It's just to test and make sure that it's even though it's seen as a string, it's a numerical value within the string. So usually this will return true, and if it is, then if is numeric is returning true, then we add the item. Now this is a tricky little method that I've never used before, but in the integer category, you do a try parse. You throw in the string here that you want to try to parse as an integer and convert it to a number rather than a text. And then you output it to a variable, which in our case is test. So now the data is stored in test and it returns a Boolean value. So if it's true, then we take what we stored in here and add it to the list. And it's already cleaned and stuff because it's only returning a numerical value. And you're feeding in a trimmed result here. So if there was any white space or anything on the end, it should be fine. So now that we've gotten the items needed names and the number amounts, what we do is we loop through here. They should, in theory, you should not have an amount that didn't have a name, so either one of these counts should work, so I used items needed. So you loop through each one of those items, and then we're going to add to the now blank missing items, and we're going to add the name by using item name at this index with a colon, and then item amounts with that index, and then we do a new line. So that's where we get each line of our display that shows us what items we need. And if you get through all of this, then it should be done because the others are just else clauses in case you didn't get there. So when we get to this point, we display the Nanite missing items, and then we add in the list that we just built. Now we have to get it to the assembler. So the first check is if the assembler is empty, the queue is empty. Now this is important because without that check, it will just feed this list to the assembler indefinitely. Like once it gets all of them added, it'll just start adding them all again. So this checks to make sure that the queue is empty before you try and add any more to it. And that missing items is not equal to the system being offline, and that missing items is not equal to no items needed. Essentially, it's saying this is empty and you made it all the way through here and rebuilt this list because it had items to be done. Even if the queue is empty, but it's offline or there's no items needed, then don't add to the queue. And then for this part is where we get into this section down here, which gets a little tricky. It's more scary, but it's not really that complicated. It's just a lot of grunt work. So what's going on here is we're looping through, again, we loop through the items needed, so how many items we have in our list. And then, again, if you'll recall, we have our blueprint and blueprint amount variables, which is a VRage my fixed point, and then this one is a my definition ID. Now, I pass the item in question, the current item's name, to blueprint maker, which is a function I built down here. So the blueprint maker, what it does is, as I said, it has to be a definition ID for the assembler to be able to queue it. So we feed in the item that we're working on, whatever item the name is, and we do a switch. And so it switches through all of these different items and checks to see if this item that we're working on equals any of this. Now I will say, at first I just copied the actual object builder blueprint definition to here, but there's a lot of things that this lists as like construction, not construction component, or detector, not detector component, and so on. So basically I had to go through and remove everything that said component from the item name, but that is how the behind the scenes VRage engine actually sees them, as a lot of these are listed as components, but they're not listed that way from the Nanite machine. So what this is basically doing is if it lists bulletproof glass, it's going to find that, and it's going to return what you're basically doing here is the blueprint definition for bulletproof glass that's part of the VRage engine. You're going to parse it into a My Definition ID, so it's something that the assembler can read. You're essentially building a pointer that points to the blueprint for the item in question. So you're checking the name the Nanite gives you against the library that the game engine has for what it actually sees it as, and feeding it back as the variable type that the assembler takes. That's really all you're doing. And as you can see, I just basically Googled how to interact with the assembler, and there was a forum post that had all of these items, which I'm pretty sure is all the vanilla items. If you were using mods, you'd have to go in and add them manually, but I'm pretty sure these are just all the assembler items the assembler can make. And when I got down here, you have to make sure that your function that all of your possible paths have a return. So I had to return one that parsed into something, but I put it as an error because, as you can see with the comment here, you should never get to this line because there should never be an item that's not on this list. So I did this for kind of syntax purposes, that the code won't run without all of them having a return branch, and I had to return a definition ID because that's the return type up here for the function. But in theory, you should never get here. And that's what turned me on to the idea that I needed to remove component from everything in the actual name, because when I first had that, I was getting ID errors, like that's not an actual ID, and it was because it was getting down here, because there were cases that it couldn't find because it didn't actually see them with the component name. So anyways, with that out of the way, that's what that function does. So essentially all we're doing is we're converting the item name into something that the assembler can use as a blueprint, as something it knows what it is. So we take the name, we convert it to the appropriate blueprint, then we take the amount and we convert the amount to a fixed point by adding it to this variable. And then when you see the assembler, I have it as assembler main, and the add queue item function, if we highlight it, it says it needs a My Definition ID blueprint, and it needs a My Fixed point. And that's where we feed those in, and then it actually can talk to the assembler, and it adds it in. The final step is the simplest. It's just write public text. This clears the text in case there was anything already on it. And then you write again and you feed in display text, which has all of our stuff that we've been compiling, and then you show the public text on the screen, and that's what will be displayed on the screen. So that's basically the code breakdown. Let's go back and check on, and this is one thing with Visual Studios. This will give you an error that says it needs to have like a return type like void or something. But if you put public void program and paste this into the SE programmable block, it doesn't like it. So even though this throws a flag in Visual Studios, just ignore that. It's not going to do anything. So with that pretty much covers all of this stuff. So let's go back over into Space Engineers and see how we did with our readout. Okay, so this is cool. This has been running in the background the whole time. I did not have enough materials, so I did turn my drill platform on and do it, but we can see the production queue here is clear. There has been no redundant adding to the list. I was afraid that was going to happen, and it didn't. So it didn't actually add any, it didn't like double the list or something that in the interim when the nano block was saying it didn't need anything to then adding the list again. I was afraid it was going to do that. As you can see here, we have no items listed. It's not building anything. We have no errors on our script, and the screen reads that there is no items needed. So the last check is going to be to run upstairs here and see what we actually got. Because if this actually worked, then yeah, everything seems to be functional. I probably will go back and add in a little excerpt thing on how to actually set it up for anybody else. Yep, so this actually got built while we were not present, and it actually built things that... I mean, it made the materials and stuff that we needed. We didn't have to go in and tell it. Now, the one caveat is with the drill platform, I don't have the script set up in a way that if the assembler needs more materials, that the drill platform will kick on and make what it needs. That's probably the next step in my production thing, and once that happens, it will be a fully autonomous building system where you can basically just place blocks down and it will just build them if it needs it, kind of thing. So yeah, that's pretty much the script. I think we're going to wrap this up here. I hope you all enjoyed. If you did, leave a like, and I will see you all next time. Now, I will say this one last little footnote. More than likely, these scripts will not be every week. It'll be when I have a script functioning like this, to where I can just show you guys how it works, here's what's happening, blah, 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 and how to set it up, and so on. But the rest of the time, I will probably be doing a Let's Build series in Space Engineers. So next week, we'll probably be doing a Let's Build. I don't foresee that I'll have another code thing set up unless I do the drill platform part of this code and make it kind of a part 2 or something like that. But so I'm also open to suggestions on code scripts and things you guys may want to see done. I can't guarantee I'll be able to figure out how to do them, but I'm open to ideas. If you thought, hey, this would be cool to have a script that did this, but I never could figure it out, send it my way. Especially if it has to do with the Let's Play series. If there was something while I was doing my Let's Play stuff and you were thinking that would be a cool thing to have scripted, then even more so let me know, because I'm kind of working on, if I don't have suggestions, I'm going to be doing scripts that help me like this. It's going to help me build faster and stuff like that. So let me know what you guys think in the comments in the meantime. I hope y'all enjoyed. If you did, leave a like, and I'll see y'all next time. Peace!